about to go over the second test and want y'all to follow along with me and make corrections to your test and see where you went wrong. I need you all to look at this so that when you all do this retest, that you all can do well. Unfortunately, a lot of us didn't do as well as we would have hoped. However, like I said, if you look at this video, you'll be fine. I'm doing this way so I don't use class time, but I still wanted to, again, to get this out to you so that you can look at it. So I'm doing this in hopes that, like I said, you look at it and you're reminded of some of the things that you may have forgotten over spring break. Okay, so number one.
Ms. Martin, please return to the main office. Ms. Martin.
Number one wasn't too much of a problem, okay? So most of us understood what a function is, okay? You understood that this was not a function. Because
Ms. DeAngelis, please report to the main office, or Ms. Walker. Ms. DeAngelis or Ms. Walker, please report to the main office.
So it was not a function because you had a value of x repeat. Okay? A lot of you identified that that value of x was in fact 0, and you understand that again. If it's a function, my x's cannot repeat. Okay, and so like I said, number one, I'm not going to waste too much time about explaining number one because you all did that correctly. What I will do is take a little bit of time on number two because again, number two was the domain. We've talked about domain. Domain is where the values of x that the function exists at. Okay, so in order to do that, you need to kind of figure out where it doesn't exist at. Okay? So I'm going to go ahead and bring this up, make this a little bit wider so we can work on it. Okay, but again, this is talking about domain. So when we're talking about domain, we need to understand that this is a radical. Okay, again, you can't take a square root of a negative number, so therefore you don't want the expression under the radical to be negative. Okay, so because the expression under the radical has to be positive, okay, we set up the following equation. Okay, so this is the equation I'm about to set up. Again, we go to our problem. We're only concerned about this 4 minus x. Again, we don't care about this 3. I'm only concerned about this 4 minus x. And because I need this to be positive, I'm going to say 4 minus x is greater than or equal to 0. We don't care if the expression is 0 under the radical. We can take square root of 0. That's fine. Okay, but what we cannot do is take the square root of a negative number. So again, we're making sure that we're saying that 4 minus x is greater than or equal to 0. At this part, it's just solving inequalities. We're going to subtract 4 from both sides. We're going to cross this out, have my negative x greater than or equal to negative 4. I want to make this reminder, though, now that we're talking about this. When I divide an inequality by this negative number, and we're dividing by a negative number because it's understood to be a negative 1 in front of this x because of that negative sign. Okay, I go ahead and cross that out. I say my x, and I need to make sure that I switch that sign. Okay, so this greater than or equal to is going to change to less than or equal to because, again, we have to change the sign when we divide by a negative number. Now, in the future, if this is an inequality and if it's a positive, my sign doesn't change. Again, I need you to understand that the only reason that these signs changed, okay, was because we divided by a negative number. Okay? And so, this would be your answer. Okay? This equation exists for all values of x that are 4 and less than 4. Okay? So the problem, even though I put it up, if you have your sheet in front of you, it did say that you can get the answer as a number line or an interval. Okay? So for my folks who decided to give it to me as an interval, okay, since it's less than or equal to 4, we need to start at negative infinity. Remember that negative infinity always gets a parentheses. We're going to do a comma. We're going to do our 4. And because of this equal sign, okay, we're going to make this as a bracket. Okay? So again, had it just been less than 4, it would have been a parentheses. Since it's less than or equal to, like I said, the equal to is the most important part of this particular problem. The equal sign gets that bracket. Okay, so this is the answer in interval notation. I would have taken this as a number line. Again, you would have had your number line. You would have had 4. You would have put your closed circle on 4 because it's including that. And then we would have shaded everything to the left. Okay. So that's your answer for 2A. Okay, that's your answer for 2A. Hopefully you can pause it if you need to, rewind it, but that's how you do 2A. All right, let's talk about 2B. Same type of problem. Okay? Again, in this particular problem, when I give you a fraction, you have to understand that the 0 cannot be in the denominator. So just like in the previous problem, it was important that you understand that a negative cannot be under the radical for your function to exist. It's the exact same thing. When you have a fraction, we've always been taught that when you divide a number by 0, it is undefined. Okay, it does not exist. So therefore, we need to find the values of x squared minus 5x plus 4 that would be 0. Because if they are 0...
Will someone from AJROTC contact 52100? Someone from AJROTC contact 52100.
Okay, because if it is 0, the function does not exist. I'm sorry for the interruptions. So what I need to do is say x squared minus 5x plus 4 equal to 0. Again, I'm trying to find my domain. Okay, so again, the only values of x that's going to make this function not exist are the values of x that's going to make this denominator 0. That's why I'm setting this x squared minus 5x plus 4 equal to 0. Then we rely on our previous knowledge and understand that, again, since this is a coefficient of 1 in front of my x squared, all I need to do to factor this is to find two factors of positive 4 that do in turn give me negative 5. Okay? Because it's a positive, I either need 2 positives or 2 negatives. Again, we're reminding ourselves of that. Because this middle term is negative, we now know that we need 2 negative numbers. Now, which 2 negative numbers do I need? I need the 2 negative numbers that multiply to a positive 4, but add up to a negative 5. And those are, in fact, a negative 4 and a negative 1. Okay? So again, this was the first step in trying to solve this problem. I have x minus 4 times x minus 1. That gives me back this function. And I'm now going to set both of these factors equal to 0. Because when I do set both of my factors equal to 0, I'm going to find the 2 numbers that make this function undefined. Okay? X is equal to 4. If I was to plug 4 into this problem, okay, again, 0 is on the denominator, undefined. 1, plug it in, 0 is undefined. What am I saying? I'm saying that these 2 numbers are the only 2 numbers on the real number line that would make my function not exist. Okay? So because this is the case, I'm really saying that x cannot be 4. I'm really saying that x cannot be 1. And so again, there was 2 ways that I can express this as on a number line or interval notation. First, I'm going to do the interval notation, okay, which some of us struggled on, and I'm going to do it one more time. Again, your real number line goes from negative infinity to positive infinity. Okay? So if my real number line goes from negative infinity to positive infinity, of course I need to start on negative infinity. However, there's a break before I get to positive infinity. Okay? So I'm going from negative infinity to 1, and I have my parentheses. I'm going to do my union. I'm going to do 1 to 4, and then I'm going to do my other union, 4 to infinity. Again, remember, the parentheses means that these 4 and the 1 are not being included. Okay, I'm saying that I'm going from negative infinity to 1, there's a break. I'm going from 1 to 4, there's a break. And I'm going from 4 to infinity, no more breaks, we're done. Okay, so this is the interval notation that satisfies this problem. Again, if you did it on a number line, the way to do it on a number line is to give me all the numbers, give me 1, give me 4. Go ahead and highlight every single number except my 1 and 4. And the way that we make sure that we're showing that 1 and 4 are not highlighted is that we go ahead and make those open circles. At this point, I would ask if everyone's clear, but you're on the other side of the screen. All right, but again, hopefully you're understanding. Hopefully you can rewind. Hopefully you can pause. Do whatever that you need to do to make sure that you understand why this is the answer that I needed for this test, and something similar is an answer that I would need when we do the retest. All right, let's move to number 3. That was worth 18 points. Okay, let's move to answer 3. Okay, this is our graphing of our piecewise function. Okay, so we have our graph. All right, and let's go ahead and graph this. This is what I needed to see on this problem. This is what I'm going to need to see for future problems. Okay? So, it asks me to graph f of negative 3. Again, f of negative 3, all these values are your x's. Your negative 3 is your x value. 0x, 2x, 1x, 4x. I need to plug this into either one of these two functions. The way that you decide which function is to use is based on the restriction that's given to you. Again, if your values are less than 2, then you are to plug your value of x into the first function. If your value is greater than or equal to 2, you are to put your value into your second function. Okay? So, because negative 3 is less than 2, I'm using the first function. And I say 2 minus a negative 3, and your answer should have been 5. Because 0 is also less than 2, I'm still using the first function. And I'm saying 2 minus 0 is equal to 2. Because 2 is part of the second restriction. Again, I'm saying that 2 is greater than or equal to 2. Since it is 2, I'm going to plug this 2 into the second function and say 2 minus 3, and that's going to be equal to a negative 1. Keep in mind, though, that I'm going to have to graph this in a second. So because I'm graphing this in a second, I'm going to put a star beside this 2, because again, there's something important about that 2. Because 2 is the number where it breaks, I need to figure out the value of 2 in both of these. However, the way to get credit for this one, if I wanted just what f of 2 is, f of 2 only exists on one of the functions, and that's the second one. All right, but like I said, I'm going to put a star beside that, and I'm definitely going to come back to that for a particular reason. Okay? Now, f of 1, even though it's tempting to go back to the second one because we're working with it, we're going back to the first one because 1 is in fact less than 2. So we're using the first one. We're going to say 2 minus 1 is equal to 1. And then 4 is greater than or equal to 2. 4 minus 3 is also equal to 1. All right, so I gave you 5 points just by knowing which of these numbers to plug into which of these functions. Okay? Now, what to do with this? Let's graph this. Okay, this first point is telling me that negative 3, 5 is a point. So negative 3, 1, 2, 3, 1, 2, 3, 4, 5 is a point. The second point is telling me that 0, 2 is a point. 0, 2 is a point. Okay? So this belongs to the first graph. This belongs to the first graph. This 1 also belongs to the first graph. Okay? This is telling me that 1, 1 is a point. Okay. Now, even though 2 jumps to the second one, again, I need to know where this ends. Okay, so only for the purpose of doing my piecewise function, I need to plug the 2 into the first one as well. Okay, and when I plug 2 into the first one as well, I'm going to get 2 minus 2 equal to 0. Okay, so I'm going to go to 2, 0, and because, again, this is on the first one, it's going to be an open circle. Okay, it's going to be an open circle. Again, I need to know where my graph stops. I need to know where it picks back up. Okay, so as soon as this function gets to 2, it stops here and it picks back up at 2, negative 1. Okay, so 2, negative 1. And I'm going to put a closed circle here. And then it takes on the behavior of x minus 3. So we're going to plot 4, 1. 1, 2, 3, 4, positive 1. Those are the only points I gave you. So if you connected those points, that was that. And that was the graph that I wanted. And that was an 18-point question. Okay, so that's how you do number 3. Again, understand that these are values of x. Understanding which function that you need to put into the piecewise function. Understanding that because the 2 showed up in both of my functions, I need to actually find both values of 2. It's just that when I ask you for f of 2, I need to go with the one that it does exist. So that's why f of 2 is actually negative 1. However, I needed to find where 2 existed in the first one, and that's where I'm going to put the open circle. Okay? F of 2 being negative 1, got a closed circle because it exists at negative 1. It doesn't exist at 0. However, to show where it stops and picks back up, I need to have an open circle and a closed circle. I need to have an open circle and a closed circle in a piecewise function. Okay? And that's how we do number 3. Number 4. Oh, that was number 4. Okay, so I actually skipped number 3. Okay, I actually skipped number 3. All right, so I'm going to come back to number 3. Okay, my apologies. All right, but that was number 4, and that was worth 10 points. I said 18 points, but number 4 was worth 10 points. Sorry for the confusion, okay? But I just did number 4. Okay, I just did number 4. Now let's go back to number 3. Okay, I don't know how that happened, but it happens. Okay, now let's go back to number 3. All right, and let's finish this particular problem. Okay? Number 3 says, again, I gave you a function of x squared minus 2x plus 3. A and B didn't give too many people too many problems. Okay? You had f of 2. A lot of you said, okay, 2 squared minus 2 times 2 plus 3. Okay? So 2 squared was 4 minus 4 plus 3. Okay? And so you got 3. Again, not a problem. Again, a lot of you put your negative 3 in parentheses like you're supposed to. Minus 2 times negative 3 plus 3 equal to, well, negative 3 squared is a positive 9. Negative 2 times a negative 3 is a positive 6. plus 3, and that gave you your 18. What I'm going to do is to do these, because again, you have these in your notes, but I'm going to demonstrate it so that you can have this to see. Again, you're going to do the exact same thing. You see how you plugged in 2 where you had your x? You plugged in your negative 3 where you had your x for b. I'm going to plug in my x plus h, okay, everywhere I see x. So again, I'm going to have x plus h squared minus 2 times x plus h plus 3. Now, this was not enough. You cannot leave this just like this, okay? We know x plus h squared, and if you don't, I need you to figure it out. Because those are one of those special rules. You can use FOIL, or you can understand that this is just x squared plus 2xh plus h squared. That's what this first term is. Then you need to distribute this negative 2 to both the x and the positive h. So you're going to have a negative 2x minus 2h, and then I'm going to have plus 3. Okay. Nothing's going to cancel out at this moment. There's nothing to combine. So this is the answer that I wanted for C. Okay, that's the answer that I wanted for C. Because now if you do C, you can do D. This f of x plus h is literally the exact same thing you just did before. So I'm going to do this for D. And I'm going to say x squared plus 2xh plus h squared minus 2x minus 2h plus 3, and it says minus f of x. It says minus f of x. F of x is x squared minus 2x plus 3. Where some of us messed up is that you forgot that you need to distribute this negative to the whole function. And if I need to distribute this negative to this whole function, the signs of x squared, negative 2x, and a positive 3 flip. Okay? And so I'm going to rewrite it again. And I'm going to have x squared plus 2xh plus h squared minus 2x minus 2h plus 3 minus x squared plus 2x minus 3. Again, you're going to see this particular problem in calculus. Okay? This is how we're going to start doing derivatives and deriving our derivative formula. So again, I need you to understand where this comes from and how to do this. And the reason why this one's important is because, again, if you do it correctly, your x squared and negative x squared are going to cancel out. Your negative 2x is going to cancel out with this positive 2x. This positive 3 is going to cancel out with this negative 3. So that the answer that I wanted for that particular problem was in fact 2xh plus h squared minus 2h. Okay? So this is what I wanted for D. This is what I wanted for C. And once again, we're going to use what we have for D in order to figure out what I want for E. All right, so let's get to the last step. Let's do E. Okay, again, this is nothing but what we just did in D. All right, so let's rewrite what we have. 2xh plus h squared minus 2h over h. If you notice, what do all these terms have in common? They have the h. So I'm going to pull out that h. And when I factor that h, I'm left with 2x plus h, minus 2. Why is that important to do? Because again, now I can cross out a set of h's. I have an h on the numerator, h on the denominator, cancel that out. And so my final answer of this problem is going to be 2x plus h minus 2. Okay? And that's, in fact, what I wanted for that particular problem. Okay? That's what I wanted for that particular problem. Okay. And then the last one for this particular page, I just wanted you to describe this function. Okay.
Ms. Walker, you have a parent in the main office, Ms. Walker.
Again, remember that my values, whether they're positive or negative, between 0 and 1, they stretch. My absolute value, like I said, accounting for positive and negative. If it's greater than 1, then it shrinks. Okay? So I needed you to tell me that the 2 shrinks the function the negative 3 shifts to the right, and the positive 4 shifts up. Okay? Again, I need you all to understand that, remember, if that number is inside of parentheses, then it's going to do the opposite of what you think it does. Okay? Like I said, that positive 4 on the outside, yes, that's up all day long. But that negative 3, okay, again, that negative 3 is shifting it to the right. All right? And that's the whole front page. That's the whole front page. Okay, we're going to talk about number 6. Okay, we're going to talk about number 6. Number 6 says we have x squared, all right, and we want to use x squared to translate. Now I want to show you something, because again, I think a lot of us had the right idea, but I want you to see how exactly it's done. Okay, and the way that I'm going to show you how exactly it's done is I'm actually going to do this. Okay, I'm actually going to do this. Okay, I'm going to see if I can bring these both up. Okay. Let's graph the parent function of x squared. Because I'm going to take a different approach for this and show you how easy this particular one was. All right. The function of x squared is a parabola. Okay, so if x is 0, y of course is going to be 0. Okay. If x is 1, 1 squared is 1. So we got 1 over here. Negative 1 squared, still a positive 1. That's the beauty of a parabola. It's an even function. It's symmetric about the axis, the y-axis. If x is 2, you can go over 1, 2, 3, 4, because 2 squared means that you go up 4. 2 squared is 4. Negative 2 squared, 1, 2, 3, 4. And then if I have 3, I can go over 1, 2, 3. 3 squared means I go up 1, 2, 3, 4, 5, 6, 7, 8, 9. If I had 9 spaces, you would get the point. Well, why did I do it this way? Because again, it asks for some precise points. And so I need you to understand how to do it precisely. So I'm going to use this function of x squared, and I'm going to sketch the first function. I want to sketch x minus 3 squared minus 5. Okay? This is telling me that I'm shifting to the right 3, and I'm going down 5. So I'm going 1, 2, 3, down 1, 2, 3, 4, 5. Okay, like I said, a lot of you put your point here. Now I just need to make it look like this, but just here. Okay? So again, if you want to do the math, you could have said 1, 2, 1, 2. Plug 2 into this equation and figure out what the value of y is. Plug 4 into the equation, figure out the value of y. Plug 5 into the equation, again, because it says it wants precise locations. But I'm going to try to teach you a way really quick while I have you on video to do this very easily. Again, from the vertex, I went right 1, up 1 to get to my order pair. Same thing, left and up 1. Let's do the exact same thing. I go right and up 1. I go left and up 1. Again, I did no math, and I'm trying to construct a parabola that looks exactly like that. And it's less work being done. Okay, well, when I went over 2, I go up 4. Well, let's do that. Let's go over 1, 2. Let's go up 1, 2, 3, 4. Left 2, 1, 2, up 1, 2, 3, 4. I even have space to do 3 because again, 3 squared is going to be 9. Go over 1, 2, 3. Go up 1, 2, 3, 4, 5, 6, 7, 8, 9. Go left 1, 2, 3. Go up 1, 2, 3, 4, 5, 6, 7, 8, 9. And now I have a parabola with very precise locations. Okay? Now pause it, do whatever you gotta do, but I want you to kind of look at these and understand that this is literally the same graph as this. I just did that shift. I literally shifted this graph right 3 spaces, down 5 spaces to make it look like that. Again, it didn't shift, it didn't stretch. All this is telling me that again, that I made it to the right and I went it down. Okay? So it didn't shrink, it did not stretch. Okay, I think I said it, probably did not say it, I know how I am, but that's that. Now, let's say you don't believe me. Okay? Let's say Mr. Small makes mistakes, you don't believe me. I challenge you just to pick one of these points and see if it works. Okay? So let's say I want this point. Okay? So what's the value of that point? That point is 1, 2, 3, 4, 5, -1. So this point is 5, -1. This point should mean that if I plug in 5 into this function, it better give me -1 as my answer. Okay, let's see. Because like I said, I'm in the business of wanting you to believe me. So when I put 5 into my function, 5 minus 3 squared minus 5. Okay. 5 minus 3 is 2. 2 squared is 4. 4 minus 5 is -1. We have that point. Let's say you still don't believe me. Okay? This point is 0, 1, 2, 3, 4. Okay, so when I plug in 0 to my function, it better be 4. 0 minus 3 squared minus 5. 0 minus 3 is -3 squared minus 5. -3 squared is 9 minus 5, and what do you know? It is 4. Okay. All right, so again, if you wanted to take that route, do so. But again, hopefully you can see this method and you can do the shift and you can make your life a whole lot easier. Is everyone clear about that? I don't know why I said that, it's just a habit, but hopefully you're clear. Okay? So now, let's do B. Let's do B. Okay? Let's do the exact same thing that we just finished doing. Okay? So I'm going to move my x squared graph over here. 0, 0. 1 squared is 1. 2 squared is 1, 2, 3, 4. Negative 2 squared is 1, 2, 3, 4. And so forth. Okay. Over here, this means that I go to the left 2. I go up 4. But then I reflect it. Okay? So instead of looking like this, it needs to look like this because of this negative. Okay, so the negative reflects it about the x-axis. Well, if the negative reflects it about the x-axis, again, just to show you really quick, we haven't changed anything. Okay? Negative x squared is still the same thing, it just goes the other way. Okay? 1, 1. 2, 1, 2, 3, 4. 2, 1, 2, 3, 4. Okay, still the exact same parabola. It just goes downward. So I'm going to do that over here. Okay? So again, I'm shifting left, 1, 2. I'm going up, 1, 2, 3, 4. And again, left 1, down 1. Over 1, down 1. Over 1, 2, down 1, 2, 3, 4. Over 1, 2, down 1, 2, 3, 4. Again, let's do 3 because we have space. If I go over 1, 2, 3, I have to square it because my parent function is x squared. So 3 squared is 1, 2, 3, 4, 5, 6, 7, 8, 9. Same thing. Go over 1, 2, 3. Go down 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and I have a nice, precise function. Okay? Now, one more time. Let's say if you don't believe me really, really quickly, let's pick a point. Okay, I'm going to pick this point. So this point is negative 1, 2, 3, 4, 5, down 1, 2, 3, 4, 5. Let's see if negative 5 is a point. I hope it is. Okay? Let's see if negative 5 is a point. Okay? So when I have negative parentheses, negative 5 plus 2 squared plus 4, I need to do order of operations. I need to take care of my parentheses first. Negative 5 plus 2 is negative 3 squared plus 4. PEMDAS says I need to do exponents next. Negative 3 squared is 9 plus 4, and it does in fact give me negative 5. So again, when I plug in negative 5 for x, it yields me a negative 5 for y. Alright, so I need you to understand that that does in fact work. Okay, that does in fact work. Alright, let's do a couple more. Number 7. Number 7 says determine whether these are even, odd, or neither. Okay? Again, I've taught you how to do it, but the easiest way to understand how to do it is to understand that again, if this is an even exponent, it has to be even or neither. I saw people putting odd. Don't put odd if this exponent is not odd. So again, if this is even, okay, then it has to either be even. Now again, let's test to see if it's even. Okay, the test to see if it's even is to see if f of negative x is still equal to the original function of f of x. And in this particular problem, f of negative x, you plug negative x squared minus 5. Negative x squared is still just x squared minus 5. So this is, in fact, an even function. Again, even function just means they're symmetric about the y-axis. And again, all you did was take the original function x squared, move it down 5, so of course it's going to be even. All right, so of course it's going to be even. Okay? Same thing with b. There's a 3 here. There's an invisible 1 here. Okay, the only test that you need to do is to see if it's odd. Okay? And in an odd function, I need to see if f of negative x is going to be equal to negative f of x. Okay? So, f of negative x is equal to negative x cubed minus 2 times negative x plus 1. This becomes negative x cubed plus 2x plus 1. Now let's see what negative f of x is. That just means we just change all the signs. X squared becomes negative x cubed. I'm sorry, that's x cubed. I'm sorry. It's been a long day. It's going to be even longer when I see you at 5. Okay? But again, x cubed becomes negative x cubed. Negative 2x becomes positive 2x. Positive 1, however, becomes negative 1. And because these end up changing, then this one became neither. Okay? That one became neither. Okay? Let me do a quick check to see if this is still recording. And we're in luck. Okay, so again, this is even, this is neither. Look at these. Again, this is the way to check this stuff, but again, I only needed to check if it was odd because I was only dealing with odd functions. This happened to be neither, but I did the odd check. This one, I only needed to check if it was even because I have even exponents. Again, it did check out, so it was even. But again, don't just guess. I saw people just guessing and just putting stuff on the paper. And again, the exponent lets me know whether I'm testing for even or odd. Okay? All right, the next one. Almost done. Okay? Almost done. So, I'm going to write this a little bit lower. Okay, actually I don't need that much space. Alright, so they gave you f of x and g of x. So again, they're going to ask, they asked us for both. So I need you to understand that f of g of x means that we're taking f of g of x. Meaning that we're dealing with the function of f of x. Okay? So f of x is my 2 minus x. But now we're replacing everything where we see x with g of x. Meaning 2 minus g of x is 2 plus x squared. Then we need to distribute 2 minus x squared. So I need to distribute this negative to the 2 and the x squared. 2 minus 2 cancels out. I'm left with negative x squared, and that's what you needed to have. Okay, that's what you needed to have. Okay. So I'm going to erase this in a second, but I'm going to rewrite this over here for a reason. So f of g of x is equal to negative x squared. And I'm going to leave this here for a reason because, again, they want to know what f of g of negative 2 is. Matter of fact, let's just do it. Okay? So, f of g of negative 2 just means I need to put the negative 2 into this function. Again, exponents have to go first. So if you're trying to do negative times a negative, don't. I have to do the exponent first. I have to say negative 2 squared is a positive 4. I then, in fact, bring down my negative, and so negative 4 was that answer. Okay. So f of g of x is equal to negative x squared. F of g of negative 2 is equal to negative 4. And now I'm going to work backwards so that you can see the last part of the problem so that you can get your credit on it next time. Again, if I have g of f of x, that means I'm saying g of f of x. That means I'm saying that my function of g of x was 2 plus x squared. And now I'm replacing x with f of x. Okay, I'm replacing x with f of x. I'm saying whenever I see x, which is right here, I'm going to replace it with whatever that just was. Okay? And what was that? You're going to have your...
Who are you talking to?
I'm recording.
I was about to fry you.
I know. Say hi to my college class.
What is it?
They're going to record this. They're going to watch this video.
Hey y'all. What college they go to? What college?
State.
Oh, I ain't going there. I might go to the How y'all doing? This is my favorite teacher.
Good. Okay, come back in 5 minutes.
You gonna be done in 5 minutes?
I am.
Okay.
Okay. So this is my x. And then my f of x is 2 minus x. Okay? My f of x is 2 minus x. Okay. Let's go ahead and solve this. 2 plus. Okay, I have my 4 minus 4x plus x squared. Okay. Then I combine my like terms. I have 6 minus 4x plus x squared. Or you could have rewrote it as x squared minus 4x plus 6. Alright, so either way you have that, that would have been that answer. Again, you need to know this rule. You need to know that a minus b squared is equal to a squared minus 2ab plus b squared. Okay? So all I did was write a little bit backwards, but it's the exact same thing. Okay? A squared, 2 squared is 4. Minus 2ab, 2 times negative x is negative 2x, times 2 is negative 4x, plus b squared, negative x squared is a positive, negative x squared is a positive x squared. Okay? So I guess I pause this, let it marinate. That's how you do that particular problem. Alright, number 9. Okay, I think that's stuck for some of us. Remember, we need to see the function, split these into 2. So again, I want to write this as P of Q of X. Okay, so this is what P of Q of X is. But I want to know what P of X was, and I want to know what Q of X. Well again, what's the Q of X? This 7x minus 5. This 7x minus 5 is what we're putting into the function. Okay? And if this 7x minus 5 is what we're putting into the function, what was the original function? You need to have a negative 4 over x to the 5th. Okay? And so that one, okay, was pretty simple if you remember the composition. Again, you put in 7x minus 5 into this particular problem, but we had to substitute that 7x minus 5 into an x that was already there. So that's why this x to the 5th is here. We didn't do anything with this 4. We didn't do anything with this negative, and that's why that would be the answer. Okay. And then the last one. Okay. Find the domain and range of the function, absolute value of x minus 4 plus 2. The first thing that you needed to know is that the absolute value looks like this. That's what the absolute value graph looks like. The absolute value looks like this because, again, absolute value of a number is always positive. So my domain is negative infinity to positive infinity, but my range for the original function of f of x being the absolute value of x is 0 to infinity. Okay? So again, my domain is negative infinity to positive infinity, but my range is 0 to infinity. Now, again, they asked us for this. We needed to know our shift. Well, this affects my horizontal shift. This shifts to the right 4. Okay? So if I was to shift this 4, my values of x are not changing. But I need to shift this up 2. And that's where things get interesting. Because again, I'm going to say 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay? If I shifted this function to the right 4, and let's do another one. 1, 2, 3, 4. But then shifted up 1, 2. Okay? My function would look something like this, where my domain is still negative infinity to positive infinity. Okay, I could put any value of x into the absolute value, and I'm still going to get an answer. But my range is going to be affected because there's absolutely no way that my range is going to be less than 2 because of this vertical shift. And so my range is 2 to infinity, and that is that answer. So like I said, I hope this helps. Sorry for all the interruptions, but I hope this helps. I hope you look at this. The retake is going to be next Thursday. I'm not sure what that exact date is. See if I can figure it out real quick. Next Thursday is the 22nd. So the retake is going to be the 22nd. Okay. As you see, it's 3:49. So I'll be seeing you all in an hour. Well, you're going to watch this after, so you would have already saw me. But long story short, I'll see you later. All right, thanks for watching, and good luck on your test.